One of the most common questions I see in the comments of these videos is, where do I start my microscopy journey? What kind of microscope should I get if I'm just starting out? Well, that is the very question we were trying to answer when we created the Microcosmos microscopes. Developed in partnership with our Master of Microscopes, James Weiss, they are a fantastic entry-level microscope, and it is available with either plan achromatic objectives or regular achromatic objectives over at microcosmos.store/microscope. And you might be thinking, I don't know what an objective is, and I sure don't know what a plan objective is or why you'd want to upgrade your microscope with them. Well, we have a bunch of information about that over there as well, and also a bunch of videos about how to use your microscope when it arrives. Also, if you previously purchased a Microcosmos microscope and would like to upgrade your objectives, we have a 4-pack of plan objectives for sale separately, as well as brand new 20x and 60x plan objectives that can be purchased individually. You can get all of that and more at microcosmos.store. Our Master of Microscopes, James, was in fact not always a master. Like everyone else, he had to start somewhere, and that somewhere was a microscopy lab course where he saw a scene quite similar to this one. There were thousands and thousands of teeny tiny things that he didn't know well enough to identify, and these minuscule unknown creatures were behaving oddly. They were gathering together on the side of the slide so tightly that it looked like they were trapped by invisible walls. Anytime one of them tried to swim away and escape those walls, it would quickly reverse its direction and swim right back, like you're leaving the house and then you realize that it's raining and cold and you immediately turn back inside. In that comparison, you are making an active decision to turn back. But for James, new to the wondrous world of microbes, it was hard to imagine why the creatures would act like that. So he asked his instructor what was going on, but the teacher just said that he was looking at some bacteria and did not elaborate. As you can imagine, this was not a very helpful answer, but it wasn't completely unhelpful either. After all, before this, James had just imagined microbes as amorphous blobs that sit around and get you sick. But seeing something like this quickly shatters that image. It makes the bacteria and the other residents of the microcosmos seem so much more alive and aware than you'd expect from, a blob. Well, that's because microbes are not just blobs. They are very well-evolved biological machinery, a product of eons of evolution that have exposed their ancestors and them to different homes and foods and threats. The machine that James was watching in action there was the flagellum, a long helical filament that either drives the bacteria towards an area or tumbles it away based on the chemical it senses in the environment. The bacteria does this with proteins on its surface, which then send a signal through the cell to control the flagellar motor. This motor then controls the movement of the flagella, which controls the movement of the cell. And as we watch more complex organisms, we can see a similar behavior. Like this Euplodes, it feels wrong to even compare them to a machine because they seem so cognizant of everything around them, even without access to all of the senses that we have available to us. But they don't have those senses because they don't need them. These microbes that we are watching have the same underlying capacity to assemble behavior out of proteins and ions and signals that our bodies do. In fact, our senses and awareness are built with those same fundamental pieces. They're just assembled on different scales of size and time and complexity. So even though the pieces are always the same, the scale of behavior and decisions are vast when you consider all of the organisms out there and all of the choices they must be facing every single day. But we journeyers through the microcosmos are fortunate that scientists have been very curious about a few species in particular and the choices they seem capable of. One species that has been particularly interesting to learn from is our favorite trumpet-shaped protists, the stentors. Stentors have kind of an odd problem for the microcosmos. They are very big. So big that they actually have to contend with non-microcosmos predators like fish and worms and insect larvae. To deal with that challenge, Stentor caeruleus has an ingenious solution. If it touches something, it curls up in a ball. It's a great solution, lovely, even a little bit cute. If a threat approaches you, curl up into a ball, and what can it really do then? Except that there's a problem. A bunch of them, really. When you're living in a pond, surrounded by other organisms that aren't fish, how do you survive if you're constantly curling up into yourself? Wouldn't that get tiring? We can see our stentors here are mostly relaxed. So how do they do that? How do they figure out what contact is non-threatening? They learn through a process called habituation. If something touches the stentor, it will contract away from the force. But if that force happens again and again and again, and especially if the force is not that strong, the stentor becomes less and less likely to contract. And stentors are able to remember this for several hours. But as much as scientists have watched stentors learn and remember, the mechanism that makes them capable of this is still mysterious to us. Another organism that scientists love to watch learn is slime mold. In one set of experiments, scientists watched slime mold move towards food through different temperature and humidity conditions. Once an hour, the scientists would expose the slime to cold, dry air during which the slime mold would slow down. When they were done with the cold exposure and returned to moist, warm conditions, the slime mold would pick its speed back up. The scientists repeated this 3 times, and then they left the slime molds alone, keeping them in the warm temperatures that the organisms prefer. But even though scientists were no longer switching things back to cold, the slime molds would, an hour later, slow down again, as if they remembered what had happened and expected it to get cold again. Some would even do it again 2 and 3 hours later. Like stentors, we don't know the machines that make this memory and behavior possible. But we are, of course, drawn to that mystery. Like bacteria drawn towards an invisible gradient, we return again and again to the questions that we have not yet answered. Can these organisms think and remember? What does it mean to think at all? Are these organisms just machines? And if so, are we just machines? The result of chemical reactions that we do not control? Or are we something more? The answers to that probably cannot be found in the microcosmos alone, but that is no reason not to look. Thank you for coming on this journey with us as we explore the unseen world that surrounds us. And if you are interested in exploring that world on your own, I will remind you there's a link in the description to the Microcosmos microscope, a microscope we made specifically for people who are starting off on their journey. It can be a little bit complicated and intimidating at first, but that microscope comes along with a few things to help you on your journey, including a mount for your phone so you can video whatever you're seeing, and also a series of videos that we made to help you get the best out of your microscope. The people on the screen right now are our Patreon patrons. They're a bunch of people who think that there should be weird, chill content about microscopic organisms on YouTube. Obviously, we agree with them, but we could not do this on our own, so we are so grateful to all of the people who help us out at patreon.com/journeytomicro. If you'd like to see your name up here, that is the place to go. If you want to see more from our master of microscopes, James Weiss, you can check out Jam and Germs on Instagram. And if you want to see more from us, there's probably a subscribe button somewhere nearby.